Hey everyone! Today we're going to be looking at finding the surface area of composite figures. Now, to remind you, composite figures are multiple shapes put together within the figure. So I'm going to be going through examples rest. I have mine circled in purple so you can take note of that. And we're going to start with number 1. How I would first approach this problem is to come up with a plan of what different shapes are in the figure, what we're trying to find the surface area of, and maybe we have to subtract out some surface areas because there are some shapes that are being overlapped. We can see that our overall figure is actually going to be a rectangular prism because remember, a prism is formed by two parallel congruent polygonal faces, and our polygonal faces here, right, are our bases. Those are our rectangles. So now what we know what shape we're working with, our prism, we want to figure out, okay, what am I trying to look for within this prism? We have the options of finding the lateral surface area, which is just looking at everything but the bases, or we could look at the total surface area, which is the lateral area kind of around the outside along with the two bases. Now, since we want to find the whole surface area of the whole thing, we're going to be looking at that total surface area. So I'm going to be referencing the formulas from our previous notes where we're looking for total surface area. So our total surface area is going to be our lateral surface area plus the area of the two bases. Now, we're eventually going to start looking at, the circles, the cylindrical parts, but let's just start off with looking at this prism, and then we can figure out how am I taking away those specific areas. Now, we kind of have, an equation with an equation. For our total surface area, we have to figure out how to find the lateral surface area first. This is done by taking the perimeter of our base and multiplying it times the height of the prism. Then we're going to, add 2 times whatever the area of our bases is. So let's start off with our perimeter. That means we're going to add 24 plus 16 plus 24 plus 16 together for the perimeter. Then for our height, we're going to take that and multiply that by 20. Now, that just represents P times H, so we have to add that to 2 times the area of our base. Now, finding the area of our base, which is our rectangle here, is pretty easy because that's going to be 24 times 16. Now let's use our calculator to help us figure out some of these values. I add all those together and I get 80 times 20, and then when I put in my calculator 2 times 24 times 16, I get 768. Multiplying 80 times 20, so 20 is 1,600, and I'm going to add that to 768. So we get, when we put this in our calculator, we should end up getting 2,368. Now, remember, that's going to represent the feet squared, and that's really looking at our total surface area of our prism. That would just be it by itself. But we also have to consider looking at the circles that are forming. Think about our cylinder and how we have this circle here open. We have to take that away from the area of our prism. We also have to take away this circle because it's already been considered as well. We don't want to have kind of that double overlap area. So what we're going to have to do is we're going to have to take away the area of the two circles. So now let's start focusing on the two circles. We know the area formula for one of the circles is pi r squared. So in order to find both areas of two circles, we're going to have 2 pi r squared. So looking at this, we can see the radius is 4. So to find, the area of all of them, right, we're going to have to take 2 times pi times the radius, which is 4, and the radius is just going to be squared. So looking at this, 4 squared is 16. 16 times 2 is 32. So we're going to have 32 pi as the area of the 2 circles. Now, something that we also have to consider in the picture, right, is this cylinder. We have to include that surface area in this as well, because we can see that's being covered too. But we just want to figure out what the lateral surface area of our cylinder is. Remember, the lateral surface area is not including the bases. We kind of already taken care of those bases of those circles we're subtracting out. Now we just want to focus on the lateral surface area of our cylinder. So focusing on just the cylinder piece, right? We're going to focus on the lateral surface area. So the formula for the lateral surface area of our cylinder is going to be C times H, where C stands for the circumference of our circle. So as a reminder, circumference is going to be 2 pi r times the height of that cylinder. So when we plug in our information, we have 2 times pi times r, which is our radius. We already know that up here is 4, times our height, which we already know that as 20. So 4 times 2 is 8. 8 times 20 is 160. So we have 160 pi as our surface area. Now I forgot to label that as feet squared, and I'm going to go back to my previous problem with the area of the 2 circles, and I'm also going to label that as feet squared, just so you know all these represent area. Now let's take all these ideas and put them together. Really, here's kind of our plan. Here's our plan of what's going to happen. We're going to take the total surface area of our prism, and we're going to subtract out the area of the 2 circles. I know that's not a really great drawn circle. I'm just trying to abbreviate as much as I can. If you want to write circles, you can do that. And then we're going to add back in the lateral surface area of our cylinder. So let's look at those values now, and I'm going to underline them so we can reference them and easily put them in the calculator. I'm going to show you the exact number as well as our approximate number if we put it in the calculator. So coming down here, we would have 2,368 feet. We would subtract out 32 pi, and we would add in 160 pi. If we keep going and work it down to be a little bit more exact, we could combine these 2 together. So that way we would have 2,368 plus 128 pi feet squared. So that's one answer we can get. That's really our exact answer. And then we'll find our approximate answer if we put that in the calculator. Okay, so go ahead, grab your calculator. Let's practice typing it on in and see what we get. Now, I use the pi button on my calculator, and I'm going to round to nearest hundredth, so 2 decimal places. When I did that, I got 2,770.12 feet squared. Either answer honestly works because they didn't ask us for a specific form, but I still wanted to show you both ways. All right, there we go. We found the surface area of our first composite figure. Woo! Let's go ahead and let's jump to our next problem, number 3. Let's go ahead and look at this next problem, number 3. Again, we can see that we're going to be looking for the total surface area of our prism, right? It's a rectangular prism, so let's set ourselves up for that. So we're looking at the prism, and we're going to be looking at total surface area. So to find that, remember it's going to be our lateral surface area plus 2 times each of the bases. All right. And then remember the lateral surface area is going to be our perimeter times our height. So the perimeter of the base times the height of the prism. And then again, we're going to add it to 2 times b, which is the area of the base. Now we can go ahead and find our perimeter of our base down here. That's going to be 9 plus 4 plus 9 plus 4. I can write that out, but I can also do that math. That math is going to be 26. Now I take that and multiply it times my height, which is 5. So we're going to get 26 times 5. We can put that in our calculator and we see we end up getting 130. Now, obviously, we have to add that to 2 times the area of the base, which is 9 times 4. If we do 9 times 4 in our calculator times 2, we're going to end up getting 72. So I'm really adding 130 plus 72. So that's going to give us a lateral surface area, our total surface area of 202 centimeters squared. Now, what's our next step? Well, let's start looking at our circles. We can see this cylinder is composed of 2 circles. This is actually pretty fascinating. This bottom circle is kind of, it's kind of counted twice because we put it on top of the prism. So really what we would want to do is we would want to subtract out that area that's double counted twice. We would really want to subtract out that circle area. But wait a minute, if we're subtracting out that area, we also have to consider how we want to add the top circle. It's not open at all, so we would want to add whatever that circle is. These two ideas, they actually cancel each other out. So I mean, in our overall, finding the surface area, if we wanted to add and figure out what the surface area of the top circle was and then subtract out the bottom circle so that way we're not double counting it, we could do that, but we don't need to in this problem. I just wanted to bring this up in case you see any problems in the future where maybe you have to, subtract out both pieces, or maybe you have to add both pieces or something like that. I still wanted to go over that idea. Okay, the last piece that we have to consider is looking at this lateral area of a cylinder. So let's start looking at the cylinder. Now remember, the lateral area is not considering the bases, and that's what we've already focused on. We focused on those circles, we talked about that, so we're looking at the lateral area, not the total surface area. All right, so the lateral area of our cylinders is going to be the circumference times the height. Now remember, circumference is 2 pi r times our height. Now, we know our radius here, right? Our radius is 2, so we could do 2 times pi times 2, and then we multiply by our height. Now, remember, the height is of the cylinder, so our height here is 3. So we have 2 times 2 times 3, that's actually 12 pi, so we have 12 pi centimeters squared. Now remember, we have to add those areas together. So let's come up with what's our overall plan in figuring out how we find, our total surface area here. So I'm going to put our plan at the bottom this time. So our plan is to take the total surface area of our prism, and, we can subtract out the circle area, so the area of the circle, and then we can add back in the area of the circle to count for the top and bottom. Again, we don't have to include that. I'm just showing you that for the future. But then we're going to add in the area of that cylinder. So that's the lateral surface area of the cylinder. Let's keep going with this problem. We know the total surface area of our prism is 202 centimeters. And we're going to add the lateral surface area of our cylinder. Remember, the areas of the circle on top and bottom, they cancel out with each other. Okay, so lateral surface area of the cylinder is 12 pi. We can keep our answer in that form. That is exact form. But we could also put this into our calculator and see what we would get. That's going to be our approximate form. So let's say I put it in the calculator, I used pi, I rounded to, nearest hundred, 2 decimal places. I should get 239.70 centimeters squared. It ends up being like 0.699, which that rounds to 0.70. All right, there we go. Let's go ahead and let's jump to number 6. So we are going to be on the 3rd page, so go ahead and skip page 10. We're going to start looking at number 11. I'm going to zoom in here, start to look at this. What's nice about this problem is we can see that this base of 2 pyramids put together, that's not going to be counted. That surface area is not going to be looked at. So we're just going to be looking at the lateral area around our pyramid. Okay, so let's go ahead. Let's start looking at that lateral area that's around the pyramid. So we're focusing, let's say, on pyramid. Ooh, that's kind of hard to read. Let's try again. Pyramid. And then let's just say it's the top pyramid. I'll call it, the top and bottom. So let's start looking at that. We want to look at the lateral surface area. So how would we find the lateral surface area of our top pyramid? Well, that's going to be 1/2 P times L. Now, what do those stand for again? Well, the P is going to be the perimeter of the base, and the L is going to represent that slant height. So we can easily see our base, all of the sides are going to be congruent, so we're looking at a square, and one side's 8, so the rest of the sides are going to be 8, so we're going to have 1/2 times the perimeter, which is going to be 8 plus 8 plus 8 plus 8, which is just 8 times 4. And then we're going to multiply it times that slant height, which is represented by L. And we can see in this case over on this side that our slant height is going to be 15. So we can go ahead, plug all those in our calculator since we're multiplying all of them, and we get 240 feet squared. That's our lateral surface area for our top pyramid. Now let's go ahead, and we're still focusing on pyramids, and now we're going to do the bottom pyramid. So since we're finding the lateral surface area, again, it's the same formula, 1/2 P times L, where P, remember, is the perimeter of, again, our base, and they both share the same base. So ironically, it's going to be 1/2 times 8 times 4. But now our slant height in this case is going to be 18. So we're not going to multiply by 15. We're going to multiply by 18. So if you want to label that as L, I'm going to do that in my picture as well. That's the lateral height for the top one. This is the lateral height for the bottom one. I like to use kind of that subscript form. All right, going back to our problem. Okay, so we're doing 1/2 times 8 times 4 times 18, putting that into our calculator. And what do we get? We get 288 feet squared. Perfect. So our overall plan, right? Our plan out of this is that we want to take the 2 areas, right, the lateral surface area of our top pyramid and our bottom pyramid, and add them together. So we're going to have the lateral surface area of the top pyramid, and we're going to add it to the lateral surface area of the bottom pyramid. And I'm abbreviating just for short. So we're taking 240 and we're adding it to 288. You can put that in your calculator if you want, or you can do it in your head. It should be 528, and it's going to be feet squared. And that's going to be our exact number. There's no approximate that we need. That's really our approximate answer is only really if we're working with pi, which is going to be working with circle shapes or cylinders of some sort. So there we go. We were able to do problems 1, 3, and 6. And now you're going to go ahead and work on examples 2, 4, 5, 7, 8. those are your homework problems. You're going to be submitting all of these at once. Now you might have to reference the notes that we've looked at the past couple days to look at all the different shapes that we've gone through, right? We've gone through pyramids, cylinders, maybe some cones, prisms. We've gone through a lot. So go ahead, pull those out, work through the problems, and hopefully maybe if you still have any questions, you can join my Zoom session, or after you submit the homework, I will put the key up so you can check your answers afterwards.